this is a review, okay? Everything you did in factoring in grade 10, we're going to do it in one day. This is all grade 10. Okay, so if you're really good at it, then you have an advantage. If you weren't that good at it, you got to get good at it. Okay, you got to figure it out, because you can't hope to pass this test if you can't factor. All right? Last year you could have got 65% in the test maybe. All right? This year you can't. All right? So, review. There's lots of ways we can factor. It's going to be a pretty short lesson. Lots of time to practice. First, and I gave you a lot of this on the review sheet, right? Factoring out by removing a common factor. It's easy when I'm telling you factor this by removing a common factor. The problem is on your test, you're just going to get an equation. It's going to say factor. You got to know which way to do it. Okay? What's a common factor? First, just look at the numbers between 15 and 5. What can I factor out? I can take a 5 out of both. They're both divisible by 5, to use that kind of wordage. Okay? Now you're done with the numbers. What can you take out of x cubed and x squared? You can take an x out. Can you take something bigger out? Can you take 2 x's out? Yes. Okay? Now, which way does your brain work? What do I times this by to get 15x cubed? Or what is 15x cubed divided by 5x squared? How do you get from 5 to 15? What's 15 divided by 5? 3. How do you get from x squared to x cubed? What do you multiply this by to get that? Or what is x cubed divided by x squared? X. Stop right there. Check it. Is this the same as that? If it's not, do not continue. Okay? Fix it. 5x squared times 3x. Is that 15x cubed? We're all okay? Yeah? Okay. Minus. What can I take? Well, is that the right wordage? How do I get from this to that? What do I multiply 5 by to get 5? 1. Let's put that there for now. What do I multiply x squared by to get x squared? 1. You want to put another 1? Okay. Do we need it? No? Okay. In other words, how's the other way to describe that? What's this divided by that? It's 1, right? Okay. Factoring is the opposite of what? Multiplying, right? Okay. So if I multiply this, if I expand this, I better get this thing again. Okay. So again, check it. 5x squared times 3x. Is that 15x cubed? Yes. Distributive law, whatever's outside the brackets times by everything in the brackets. What's 5x squared times 1? 5x squared. Okay? That's the same as that. So it's factored. You can go back and forth forever. Okay? I can multiply it and get this. I can factor it to get that. Okay? Factoring is the opposite of multiplying. Looks kind of messy. All right? Like I said in grade 10, you should never get one of these wrong because you can always check it to make sure you didn't change it. Just like converting radicals. We're not changing it. We're just converting it. We're just factoring it. Okay? Making it factored. Okay? This looks like a trinomial, right? But this is nice because we're going to follow these instructions. Let's take out a greatest common factor. What is common between all three terms? What can I take out of those? A 4. What do I have left? If I take a 4 out of 8p cubed, I have 2p cubed. Stop right there and check it. Is this times this equal to that? Yes, it is. Okay, if I take a 4 out of 4p squared, what do I have left? P squared. Is 4 times p squared equal to 4p squared? Yes. If I take a 4 out of a 4, what do I have left? Yeah, is 4 times 1 4? Yes. Okay, I've already checked this. And we don't know how to factor a cubic. That's what you call this thing, because it's got a 3, power to the 3. So we're done. Okay? It's fully factored. Now this one looks a little different. All these terms were separated by a sign. A minus. A minus. Where's the sign here? Right there. So there is this term and there is that term. There's two terms here. What's common in both two terms? What can I take out of both two terms? Do they both have a y plus 2? Then I can take it out. Hang on. Yeah, he's one step ahead. Take out a y plus a 2. Out of this term, what do you have left? I have 3y. Okay? Stop right there. Is this times this equal to that? Yes, it is. Okay? Minus, if I take out a y plus 2, what do I have left? A 9. Okay? But I have to bracket that. Otherwise, that y plus 2 is not multiplied by that minus 9. Okay, let's check it again. Y plus 2 times 3y is 3y plus 2. Y plus 2 times minus 9 is minus 9y plus 2. That's the same as that. Okay? Now it says factor. When we see factor, factor completely. Ignore that y plus 2 for a sec. Just look at this. If that's all you had, like Lewis was saying there a minute ago, is there something I can factor out of that one? Yeah. I can take a 3 out of here. I can take a 3 out of here. So I still have y plus 2. Can't do anything with that. But I can take a 3 out of there. What do I multiply 3 by to get 3y? A y. What do I multiply 3 by to get minus 9? Minus 3. So now that's fully factored. Normally, where do we put our 3? At the front. So that is the same as this. Okay? It doesn't matter what order you multiply in. Okay? But we usually have our number out in the front. So that was a difficult question in grade 10, but it was given, okay? Maybe it was like one question on the test. But now, if we can't do that, guys, you'll be fighting for a C+, okay? That's the first one. What's the second one on our list? Difference of squares. Okay? Factor. if possible, oh that's lovely, using, here it's telling you how to do it. But like I said, on your test, you're just going to be getting that. You got to know that maybe that's a difference of squares. If it's two terms, you have to think to yourself, difference of squares. Okay, what's the square of x? It's x squared. What's the square of 9? It's 81. And what's another word for difference? Subtract. That's why it's called a difference of squares. Okay? This is the square of x. That's the square of 9. And there's the difference. How do we do this? Just like trinomials, by inspection, throw down a couple sets of brackets. Can I take the square root of x squared? Yes, I can. It's x. Can I take the square root of 81? Yes, I can. It's 9. If I go plus minus, what do we call that again? Starts with a C. Ah, conjugate. The middle terms cancel out, right? You should never get these wrong, because you can check it. If I FOIL this, what do I get? X squared minus 9x plus 9x minus 81 difference of squares. They're nice to factor if you recognize it. Okay? Is this a difference of squares? Here's what you got to ask yourself. Can you take the square root of it? Yeah, because remember, the square root of a perfect square is just the thing itself, right? The square root of a perfect square is just the thing itself, because I can write that as 3 squared x squared. What's the square root of 25a squared? 5a. What's the square root of 49? 7. How do I make this work? How do I get my middle terms to cancel out? Yeah, but for a change, let's go minus plus. Is that going to be any different? No, doesn't matter. Because remember, I can multiply this any order I want. Just switch them around. Doesn't matter, right? A times b is the same as b times a. Okay. Is that a difference of squares? Can I take my? It's not. It's checking it. It's multiplying it to make sure I got the same answer. Yeah, that's not the answer. This is. This is factored. This is factored, right? Factoring is the opposite of multiplying. I'm multiplying it to check it, to make sure I didn't make a mistake. It's got to be the same thing, right? We're not changing it. Just like radicals, we're not changing it. We're just making it look something different, okay? All right, can I take the square root of 9x squared? Yeah. Can I take the square root of 4? Yeah. Can I factor this? No. Is that a difference of squares? It is not. Remember, if possible, everybody loves those, I can't do that. That's not a difference of squares. I don't care how hard you try, you throw down 2 sets of brackets, you won't be able to come up with anything. Okay? Try to remember that. It's not a difference. There is no addition of squares. There's no rule. There's nothing special about it. Okay? Can I take the square root of 16t squared? Yep, 4t. Can I take the square root of 64? 8. We seeing a pattern happening here? Plus, minus, I'm done. Okay? These are nice to factor, guys. You want to see a difference of squares. Okay? Greatest common factor, difference of squares. What's the next one? Trinomials by inspection. Just going to wait or? Okay. All right. Okay, that's a trinomial. Tri-3 has 3 terms. We can do these by inspection because the number here is a 1. Okay? If they're small, like these are, we're just going to throw down a couple sets of brackets and see if we can piece it together. Tomorrow we'll do the ones that are a little more difficult. Okay? Like 12b squared. Well, 12, I don't know what to put there. Is that 12 times 1, 4 times 3, 6 times 2? Okay? All right. So, but don't worry. Today, we're just going to throw down a couple sets of brackets, piece it together. What's my options to get to a squared? That's what times what? You only have one choice. A times a. Okay? That's the F in FOIL, right? A times a is a squared. What's the last in FOIL? How do I get to 30? Now you got to look at this middle number. Is that 30 times 1 or 15 times 2? Or is it something else? 10 times 3? Are there other options to get to 30? Oh yeah, 6 and 5. Which ones add to 11? Okay. Check it before you go on to the next question. You should never make a mistake. A squared and 6a and 5a and 30. Is that the same as this? Check. Okay. Let's do this guy. What times what is x squared? X times x. Now 48. How do I get to 4? And if you want to do this, what multiplies to 48 and adds to 4? What two numbers? Because I got lots of options for 48, right? 48 times 1, do those add to 4? No. 24 times 2? No. What's next? 12 times 4? No. What's next? What's half of 12? 6. So twice what 4 is 8. 6 times 8? No. What's my other options? 16 times 3. Do we see any combination that adds to 4? Okay. Don't we love this? Sometimes they don't factor. Okay? I know we're going to sit there pulling our hair out, going in circles. Could be a 20-minute question. Don't assume they all factor. None of those, there's no two numbers that multiply to 48 and add to 4. Okay? And lastly, for this one, for this trinomials by inspection, do you want to try to piece this one together, or do we want to try to do something first? What multiplies? Okay. Yeah. X cubed. Do you know how to do that? Is there a common factor you want to take out first? Can I take a 3x out? That will make our lives a lot easier. Okay? So anytime you can take out a greatest common factor, you do it first. I want this trinomial to be as small as possible before I factor it. Okay? If I take 3x out of 21x squared, what do I got left? 7x. If I take 3x out of 36x, what do I have left? 12 times 3 is 36, and there's my x. That's a lot nicer to factor. So this trinomial, throw down a couple sets of brackets, do it by inspection. What times what is x squared? X times x. What two numbers multiply to 12 and add to negative 7? Okay? Everybody okay with that? Negative 4 times negative 3 multiplies to positive 12 and adds to negative 7. It's factored. But check it. If you multiply this out, it better be the same as that. Multiply this out, it better be the same as that. You okay? Okay. All right, last one. Grouping. This is what's going to help us tomorrow factor trinomials that we can't do by inspection. Okay, factor by grouping. We have 4 terms here. Okay, if we recall, I could combine these and get minus 3x. That's my trinomial. This is helping us. They've already broken this up into the things I want to in order to factor this. Okay, because this isn't one that can be done, like say that one can't be done, what can be done by inspection, but your life's probably a lot easier if we see a new method. Again, I'm going to show you that tomorrow. All right, all we want to do here, look at the first two. What's the greatest common factor between those two? I can take an x out. What do I have left? X minus 5. Okay, multiply that out. Is that the same as this? Yes. Look at the next two. What can I factor out of those two guys? I can take a 2 out. What do I have left? X minus 5. Now, look, I have something in common. That looks like this guy. Y plus 2, y plus 2, factor it out. X minus 5, factor it out. What do you have left? X plus 2. Fully factored. Okay? Quickly, let's check that. X squared plus 2x minus 5x minus 10. Is that the same as this? Check.
So, what's the difference if you do that, or if you just add negative 5x plus 2x?
Well, this is how we want to see it. I'll show you why tomorrow. But if you want to take that and do that by inspection, we'll get the same thing. Today, no. Don't worry about it. You don't want to do it that way. We're telling you to do it this way for a reason. You'll find out tomorrow, okay? No. If it says factor by grouping, don't combine them, leave them separate. Okay. What can I take out of those first two? Yeah, a 3 out of the numbers, a y out of the variables. What do you have left? 2y. What do you have left here? 3. Guess what I want out of my second set of brackets? What do I have here? So what do I factor out to get the same thing in my brackets? A 1. Okay? That's the only way it's going to work. I have nothing to factor out. But remember, if I don't have the same thing in these brackets, how am I going to factor that out and make this two binomials? I have to put a 1 here. Factor out a 1. Check this. Multiply it. Is this the same as that? Yes. Is that the same as this? Yes. 1 times 2y is 2y. 1 times 3 is 3. This is the same as that. But now, what can I factor out of this term? What can I factor out of this? Okay. 2y plus 3. What do you have left? Let's use nice green. 3y. If I don't have that plus 1 there, it won't be this. Okay? It won't work. 6y squared, check. 2y, check. 9y, check. 3, check. Okay? So that one's a little trickier. That would have been a hard question in Math 10. Now Math 11, we need to know it. Okay? We need to put that 1 in there. We need to factor out a 1. Yeah, that's a tricky question in grade 10. Okay? Now lastly, guys, I'm not much for English, but that's the flow chart we're going to use right here. Okay? This is helpful. Yep, that exact table was in your grade 10 book, yes. All right. Well, if it's helpful, use it. If not, then don't. Okay, 1 to 4, 6 to 9. Guys, if we don't do this, how well do we think we're going to understand what's going on tomorrow? Not very well.